Hi guys, I'm back with yet another video, and in this one we're going to be talking about how to represent area with an expression or two. We're going to use the distributive property to help us. So for the practice problems at the end of the video, you'll need a paper and a pencil. You probably remember that area can be found, area of a rectangle I should say, can be found by multiplying the length times the height, or the base times the height, or the length times the width, or whatever you want to call those dimensions. Basically, the two dimensions multiplied by each other. So in this example here, you can see 6 feet by 2 feet. That gives us an area of 12 square feet. Okay, so the focus of this video is what happens if one of the dimensions is unknown, or what if there are two parts, or what if there are two parts and one of the dimensions is unknown. I'm going to show you how to deal with those three situations. First, what if one of the dimensions is unknown? So in this case, you can see we have a rectangle, and we know that this dimension is 3 centimeters, but we don't know what this dimension is. And yet, you're still asked to give the area. Well, 3 times this unknown length, which we've called x, is 3 times x. So that your area would just be 3x. That doesn't give you like an actual numerical value, but that is how you would represent the area of that rectangle. Okay, so what if there are two parts to our rectangle? Like, for example, I want to know the area of my backyard and my neighbor's backyard. Two different parts next to each other. Here is how we would handle that. So we find the area of the two parts and then we add them together. You can see this long skinny rectangle has an area of 40 square feet, because the 10 square feet across the bottom times the 4 square feet here gives us 40 square feet. This smaller area is 20 square feet because 5 times 4 equals 20. And then we just add those two areas together to get a total of 60 square feet. So what happens then if there are two parts and one dimension is unknown? That's where the distributive property really comes in handy. Here's an example of that. Let's say we had a length of 8 centimeters next to a length of 2 centimeters, but we didn't really know the width of this figure. So 8 times x would be the area of this rectangle, because our unknown here is x. And 2x would be the area of this smaller rectangle, because 2 times x equals 2x. When you add them together, you get 8x plus 2x, or 10x. But we can show that two different ways, actually 3 different ways. We can show the 10x, or we can show the factored form, x times 8 plus 2. That's this side times these two sides, or these two parts of this side added together. Or we can take the expanded form, which would be the 8x plus the 2x right here. In either case, they simplify to 10x, so that's like a double check to see that those are actually equivalent expressions. Same question. What happens if you have more than one part and an unknown area, or an unknown dimension? So here's an example, except it's not the side that they have in common that is unknown. It's one of these bases that is unknown. So in this case, we have 8 times something, 8 plus something times 2, I should say. So 8 times 2 gives us the area of this rectangle here, 16 square centimeters. And x times 2 gives us the area of this rectangle here, 2x square centimeters. And just like with our previous example over here, you can write this in factored form. The side that they have in common is the 2, that goes out in front of the parentheses, and then the 8 plus x would be this entire base that would go inside the parentheses. Or like I did up here, you can find the area of each of the rectangles and add them together. And in this case, you can't simplify any further because we can't, we've already combined all of our like terms. 16 and 2x are not like terms. We can't combine them. So that's as simple as we could get in this case. So here are some practice problems for you. And I will reveal the answers in just a moment. Here's one and the answer. I said write 2 expressions. Some of them actually are going to show up with 3 expressions. You could have written any of those 2. I mean any 2 of those 3. Problem number 2. And the answer. Only 2 expressions are possible there because you can't combine those. They're not like terms. Problem number 3. Has 3 possible expressions. You could have written any 2 of those 3. Problem number 4. And here's the answer to that. 2 expressions only because we don't have like terms to combine here. So I hope that makes sense.